Hi everyone and welcome to the Learning Curve Academy. In this lesson I will be looking at the factorization of quadratic equations, and we'll be using this technique to both come up with the factors of the quadratic equations as well as to solve the quadratic equations. Now a quadratic equation takes the form of y equals ax squared plus bx plus c. Quadratic equation in this form is said to be in its standard form, where you realize here a is the term multiplied by x squared, b is the term multiplied by x, and c is our constant. So when you're factorizing a quadratic equation, and factorization is one of a few methods that can be used to solve a quadratic equation, and as part of my series on quadratic equations, this is the first in my series on quadratic equations, I will also be looking at the other methods of solving quadratic equations, because not every quadratic equation can be factorized, and I will also be looking at how to graph quadratic equations. So when you're factorizing a quadratic equation in standard form like this one is, the first thing to identify is the value of a, b, and c. Now a here is 1, which is the invisible coefficient of x squared here. It's an invisible 1 right there. B is equal to 5, which is the coefficient of x right there. And c, which is the constant or y-intercept, is 6. Once you have written down a, b, and c, the next thing you want to do is to multiply a by c. And a is 1, c is 6, so 1 multiplied by 6 is 6. Then I draw a little t here, because my next step is to now try and find two numbers that can be multiplied to give us AC and also added to give B. So in other words, we're trying to come up with two numbers here whereby when I multiply them, I must get the value of AC, which is 6, and I must get the value of B, which is 5, when I add those same two numbers. And so what we look at here, 3 and 2 is a very easy choice. 3 multiplied by 2 gives us 6, and 3 plus 2 will give us the value of b, which is 5. So the condition has been satisfied. And now what we're going to do is that we're going to use the 3 and the 2 to substitute into the original quadratic equation here that we have in standard form. We're going to use the 3 and the 2 to replace the middle term of 5x to re-express this quadratic equation. So this will become x squared plus 3x, yes, so it's going to be x squared plus 3x plus 2x. This is the 3x and the 2x from here that we're substituting to replace the 5x, which is the bx in the original quadratic equation, plus 6, yes. And once we do that, our next step is to try and organize the terms here into pairs using the exact format that they are currently in. So I'm going to put x squared and 3x together, and I'm going to put positive 2x here and 6x together. This is positive 2x plus 6. There we are. Now I will come up here, and what I'm going to do is that now that I have organized the quadratic into pairs, I'm going to identify the highest common factor in each pair. Starting with x squared plus 3x, the highest common factor, that is, the highest term that can go into both x squared and 3x is x. So I'll factor out x. And then I will divide that x into both x squared and 3x. So x divided into x squared will give us x, because x multiplied by x would give us x squared. And then x divided into 3x will just give us 3, because the x will cancel, leaving us with 3. So that takes care of the first pair here. We found the highest common factor, which is x, and then factored it out. Then we go to 2x plus 6. And we say, what is the highest common factor? That is, what is the highest term that can go into both 2x and 6? And that's positive 2. So we factor out that positive 2 and say positive 2 into 2x divided into 2x will just give us x because the 2's will cancel each other. And then this positive 2 divided into positive 6 will give us 3. And we close that bracket. So now we realize that the terms inside the brackets here are the same, which is a requirement. If you have done the factorization correctly, the terms inside the parentheses will be the same at this stage. So I write down that common term of x plus 3, that common expression of x plus 3, and then I pair the other two terms of x and 2 together, so I get x plus 2. So the solution here would be x plus 3, x plus 2. This is the solution in terms of factors. These are the factors of the quadratic. All right, so we have two factors here for this quadratic. What we're going to do now in order to actually solve the quadratic is to set each of these factors equal to 0. By setting each of these factors, x plus 3 equal to 0 and x plus 2 equal to 0, we will be able to solve for x, and those values will represent the actual solutions, or in other words, the x-intercepts for the quadratic. So since x plus 3 is equal to 0 and we want to isolate x, by inverse operation, we will do subtraction of 3 here, because 3 is added to the term that we're trying to solve for, which is x. We will actually do the inverse of addition, which is subtraction of that same number. So we'll subtract 3, and what you do to one side of an equation, you must do to the other side as well. So we'll also subtract 3 from the right hand side. So 3 minus 3 here would give us 0, leaving us with x on the left hand side of the equation. And 0 minus 3 gives us minus 3. So one of the solutions for this quadratic is therefore x equal negative 3. On the right hand side of the quadratic, we'll use the same procedure. Sorry, in terms of the other factor, we'll use the same procedure, which is x plus 2 minus 2, because we have to minus 2 to get rid of this positive 2 here. And we're going to do that to the right hand side of the equation as well. So x plus 2 minus 2 is going to be x plus 0, or just x, and 0 minus 2 is going to be minus 2. So therefore we end up with the solutions for this quadratic, or in other words the x-intercepts for this quadratic, are negative 3 and negative 2. And that's how we solve a quadratic equation in standard form. Now we're going to look at this second one here. Y equals x squared minus 2x minus 15. Again, what you want to do first and foremost is to write down the values of x, yes? When you write down the values of x here, you get a equals 1. There's an invisible 1 in front of the x squared. B is equal to negative 2. And c is equal to negative 15. Okay? And once you have written down these values, then you multiply a by c. And when we multiply a by c here, that's 1 multiplied by negative 15, which is of course negative 15. So since we have now found AC, which is negative 15, we now need to find two numbers that can be multiplied to give us b, which is negative 2. And thinking about it, those numbers would be 3 and negative 5. When you multiply 3 by negative 5, you get negative 15. And when you add 3 and negative 5, you will get negative 2, which is b. And therefore, the conditions for us to carry out factorization using these two numbers have been satisfied. So what we will now do, as illustrated before, is to use these two numbers that we have come up with to replace the middle term, that is the negative 2x. So we're going to have x squared plus 3x, that is this 3 here. And then we're going to say minus 5x. Because we are replacing a term in x, which is the negative 2x, then it is necessary for these terms to also have x. So it's going to be x squared plus 3x minus 5x. And this is of course minus the 15 that was there before. So I'm now going to organize this into pairs. as we illustrated before. So this becomes x plus 3x. We'll put that in a parentheses. And then the other two numbers that we have here are negative 5x and negative 15, which we will also place into parentheses. Now that we have placed these into pairs, what we need to find out for each pair, starting with x squared plus 3x, is which number, what is the highest common factor? What is the highest expression or number or term that can go into both x squared and 3x? And that's of course x. X can divide into x squared x times, and x will divide into 3x 3 times. So this answer is therefore x plus 3. And then for the second pair here, which is minus 5x minus 15, the highest common factor is minus 5. So I'll factor out minus 5. Minus 5 goes into negative 5x x times, because the negative 5's will cancel each other, leaving us with x. And then negative 5 divides into negative 15 positive 3 times. A negative divided by a negative will be positive. So what we realize here now is that the terms inside the parentheses here, the expressions inside the parentheses are the same, and that is a requirement if the factorization has been done correctly. So this gives us x plus 3, writing down that common expression that we came up with, into the outer terms are x and minus 5. So that's x take 5. And those are the factors of this quadratic. These are the factors that we have come up with. Once you find the factors of a quadratic, if you were to multiply out those factors, then it will give you back the original quadratic. So that's one way you can always check if your factors are correct, by multiplying them out to see if it gives you back the original quadratic equation. So those are the factors of the quadratic, and as we illustrated before, to actually solve, or in other words, to come up with the x-intercepts, we set each of those factors equal to 0. So we're going to have x plus 3 equal to 0, and also x minus 5 equal to 0. We set these equal to 0 to get the x-intercepts, which are the solutions for the quadratic. That is the points where the graph of this quadratic equation would actually cut the x-axis that represents the solutions. So what we have here now is x plus 3, and we want to get x on its own, so we will carry out inverse operation of minusing 3 from the left hand side of the equation, and what you do to one side of the equation you have to also do to the other side. So I'll have 0 minus 3 on this side, and we do this kind of operation to maintain balance in the equations. So I'm going to only be left with x on this side, because 3 minus 3 is 0, and this is equal to negative 3. And then here I have x minus 5 equal to 0. So we're going to do a similar thing here. We're going to say x minus 5, and the inverse of minus 5 is plus 5. So that is what we will do to get rid of the minus 5 and leave x on its own. And what you do to one side of an equation, you have to also do to the other side. So on the other side, I'm going to have 0 plus 5. Now negative 5 plus 5 here is going to be 0. So x would be equal to 5. And so we have now come up with the solutions for this quadratic, which are x equal negative 3 and 5. Remember that the solutions for an equation, such as a quadratic equation in this case, represents the x-intercepts. And this is the first in a series that I am doing on quadratic equations, which will include the methods of solving quadratic equations, factorization, using the quadratic formula and completing the square, and also sketching the graph of quadratic functions, requiring that we find the x-intercepts, the y-intercept, and the turning point of that quadratic function. I hope you found this to be a lesson in learning. Much more to come. Thank you everyone, and remember to like and subscribe.